Hi, in this video, I'll be solving this algebra problem where you're given a sum of several numbers and you're asked to write it in summation notation with the sigma symbol. Before I do that, let's back up a little bit and talk about the sigma symbol itself. For example, if you're given this sigma notation, sigma I from 1 to 4 of 3 over I. What this says is the letter I will go from 1 to 4, and each time you plug it into the formula here, first you have 3 over 1, and then you have 3 over 2, and then you have 3 over 3, and then you stop at 3 over 4. The formula tells you how to change each term. And then you add them together and you get some sort of an answer. Great. Well, for a problem like this, you go the other way around. You're given all of these terms that change, and you're supposed to look at how they change and sort of deduce back that this was the formula. So you need to look at it and see what changes and what doesn't change. The 3 doesn't change, so this is just 3. But the numbers down here change, and lucky for you, they change exactly as I is, so you recognize that it should be just a letter I. Obviously, for these two examples that we're seeing here, the numbers don't change exactly as I, but we can handle that. The principle is the same. You look at each of the terms, you see which part of it changes and which part of it doesn't. The 3 doesn't change, you just write down 3. But the denominator, the 1, 2, 3, 4, they change. So you look at it and you see what kind of pattern you can recognize from it in order to write it into the formula. That's our strategy. Our strategy would have step number 1, look at the terms, see which part, could be multiple parts, stay constant, which parts change. Step 2, recognize a changing pattern. And number 3 is write the changes mathematically with respect to I. That's our strategy. Now let's apply it. All right, let's do part A. Part A, I have a bunch of fractions, and they all change. The whole fraction changes. So that means the numerator changes and the denominator changes. I'm going to work with one part at a time. Separate them out so I don't get confused. First, I'm going to work with the numerators, and then I'm going to work with the denominators. The numerators go 4, 6, 8, 10, 334. What is the pattern of the change here? You guessed it. They go up by 2. Increase by 2 each time. If it increases by 2, then that makes it an arithmetic sequence. At this stage, there are 2 ways you can do this. You can recognize it as an arithmetic sequence, and you apply what you know about arithmetic sequence. It starts at 4, and it adds by 2 each time. But you didn't add on the very first step. You only start adding on the second step. So it's 2 times I minus 1. And you can verify that. If you plug in I equals 1, then you get 4 plus 2 times 0, which is 4. So that's correct. And then I equals 2 is 6. So it's all good. And that is if you can recognize an arithmetic sequence and write the terms of it. Now, if you cannot do that, or you forgot how to do that, you can do it a little bit longer way. And that is, well, you know that each time you add 2, that means over many terms, you add 2 many times. Adding the same number many times means you multiply by that number. Adding 2 many times means you multiply by 2. The AI term will involve a 2i. Starting somewhere, right? You add on to something. So there's a blank here plus 2i. And you want to know what the blank is. Well, to figure out what the blank is, let's plug in I equals 1. Then a sub 1 is equal to the blank plus 2 times 1. And a sub 1 is supposed to be 4. So this is supposed to be equals to 4. That means the blank is a 2. 2 plus 2 equals 4. The blank is 2. I put it in here. So AI is equal to 2 plus 2i. And you might say, wait, how come I have 2 different answers? They look like 2 different answers, but they are actually the same answer. Because if you expand out, the first answer here, you get 4 plus 2i minus 2, and 4 minus 2 is 2. So it's 2 plus 2i. It's actually the same answer. They look different, but they are the same. 2 possible ways of writing the numerator. Now I work with the denominator. The denominator goes 5, 8, 11, 14, all the way to 500. What is the pattern? The pattern is that you're adding 3 each time. 5 to 8, that's a plus 3. 8 to 11, that's a plus 3, etc. Okay, so it's an increase by 3 each time. Therefore, it's an arithmetic sequence starting with 5 plus 3 times I minus 1. That's my AI for the denominator. Again, if I couldn't figure out how to write it as an arithmetic sequence, I can always do it the long way. And that is, if I'm increasing by 3 each time, then overall I'm adding a 3i. And I just need to figure out what the starting value is. Well, when I is equal to 1, then a sub I, this is a sub I, is equal to some blank plus 3i, and that number is supposed to be 5. So this is equal to 5. Well, a sub 1, that means I'm substituting in 1 for I. And that tells me this blank here is supposed to be the number 2. I have figured out the mathematical formula for the numerator and the mathematical formula for the denominator. Therefore, I have the general formula of sum of numerator 4 plus 2 times I minus 1 over denominator 5 plus 3 times I minus 1, with I going from 1 to n. Or I could write it in other form, 2 plus 2i over 2 plus 3i. Am I done? Almost. I'm still missing this number up here. I'm supposed to fill in that number. So to find n, then I'll just look at the last number. N is the last number. The last term is 334 over 500. And that is supposed to be what I get when I plug in n. I'm going to use the first form. If you use the second form, it works the same way. And this is supposed to be equals to 4 plus 2 times n minus 1 over 5 plus 3 times n minus 1. This is supposed to be the numerator, and that is supposed to be the denominator. I can pick either of them to solve for n. 4 plus 2 times n minus 1. That's the same as 4 plus 2n minus 2. I subtract 4 and plus 2 both sides. Have 332 is equal to 2n. And therefore, n is equal to 332 divided by 2, which is 166. I could also have worked with the denominator, which is a good idea to do it now to double check my work. I'm going to go 500 is equal to 5 plus 3 times n minus 1. Subtract 5 and add 3 both sides. I have 498 is equal to 3n. N is equal to 498 divided by 3, which is equal to 166. Right, I'm going to plug in the n here, so I'm going to just copy it down here. The answer is I from 1 to 166 of 4 plus 2 times n minus 1 over 5 plus 3 times n minus 1. Or if I were doing it the other form, the simpler form, it would be 2 plus 2n over 2 plus 3n. Final answer. Now part B. Strategy is still the same. Step 1, see which elements change from term to term. Step 2, recognize the pattern of the changes. And step 3, write it mathematically with respect to I. Oh, look, they don't change. If they don't change, then they don't change. They remain x plus 5 over x minus 5 the whole time. Remember the example I started with? I started with sum of 3 over I. The x plus 5 is like the 3 that doesn't change. So it just goes directly into the formula. It doesn't change with I. It changes with x. But in writing in sigma notation, we're looking for changes with respect to I. The x plus 5 does not change with respect to I, so it just stays x plus 5. Just like the 3 stays a 3. The x minus 5 doesn't change with respect to I either, so it's just like another 3, but it's in the denominator. Well, that's it. That's the pattern. And now I just need to fill in the blanks here. I from 1 to, well, this one I'll just count off. 1, 2, 3, 4, so it's 1 to 4. And that's my final answer. Hope that helps. Questions? Ask in the comments. Thanks for watching. Bye.